in our sky is this one, Betelgeuse or Betelgeuse. It's a red giant star. If you put it where the sun is, it would extend out to the orbit of Jupiter. It's enormous. It's very unstable. It's about to explode.
Is the end of Betelgeuse imminent? There is no question that the gigantic star will one day leave the cosmic stage in a brutal explosion, but according to some researchers, the elemental spectacle could occur much earlier than previously thought. But what does this mean for us? Will the colossal supernova also plunge our Earth into chaos? And why is the shoulder star of Orion currently exhibiting behavior that leaves astronomers baffled? Bigger, the Sun. In our everyday perception, our mother star often embodies the cosmic measure of all things which no other celestial body can match. And in relation to our home system, this is absolutely true. With a diameter of no less than 1.4 million kilometers, the Sun easily outshines all its planetary companions. In theory, the Earth would fit into the Sun more than 1.3 million times. In practice, however, our central star begins to shrink further and further when we compare it with other galactic giants. Located in the constellation Orion, Betelgeuse trumps our fixed star in every conceivable astronomical respect. In detail, the giant star, which is internationally known as Betelgeuse, has a diameter 800 times that of the Sun. In this constellation, the Sun is transformed into a tiny pinhead that would fit 500,000 times in the shoulder star of Orion. The differences in luminosity are no less extreme. Betelgeuse shines 10,000 times brighter than our source of heat and life. As a result, it's even possible to see the celestial body, which is around 650 light-years away from Earth, in the night sky with the naked eye. If you are in the northern hemisphere during the winter, it is practically impossible to miss the red supergiant, and not just since yesterday. In fact, Betelgeuse was already mentioned 2,000 years ago as a yellow-orange glowing dot in the firmament. But like all other objects in the universe, Betelgeuse is not a fixed, unchanging object. Quite the opposite, the determination of its radius using interferometry revealed that it fluctuates by around 15%. Interesting to know, Betelgeuse's radius was the first to be determined using this measurement method. The bottom line is that the fluctuations are by no means limited to the radius. They also affect the brightness. Accordingly, a visible change in luminosity occurs every 2070 days, a phenomenon that is in turn due to the late stage of development in which Betelgeuse now finds itself. In principle, red supergiants have the characteristic of expanding and contracting again, whereby this pulsation is directly linked to the fluctuations in brightness. However, a few years ago, experts were made acutely aware of just how drastic and above all, how puzzling this spectacle can be sometimes. An inexplicable interplay back then, in October 2019, a process began that ultimately led to an extreme reduction in luminosity. In February 2020, this was no longer even 40% of its average initial value. Since the beginning of astronomical studies, Betelgeuse had never shone so faintly. After experts became aware of this mysterious event, they immediately tried to decipher the reasons behind it. Some researchers saw the loss of luminosity as nothing more than the result of several overlapping brightness cycles. Other experts, however, feared that the incident was the result of something far more dramatic, an imminent supernova. In principle, the approaching stellar explosion announces itself by the celestial body expanding greatly and experiencing a significant decrease in brightness in the same breath. However, as no star has yet been observed directly before a supernova, we do not know whether such a dimming occurs several years or just a few hours before the actual event. However, there is no doubt that Betelgeuse will one day make an explosive exit. According to our current state of knowledge, however, the red supergiant will only bid farewell to the cosmic stage in the distant future. It only reached its final stage comparatively recently. The final supernova is likely to be a good 1.5 million years away. However, other researchers have set a much tighter time frame and estimate that Betelgeuse will disappear from the space maps within the next 100,000 years. After Betelgeuse literally shone again in its former glory in April 2020, scientists were able to uncover the cause of the drastic drop in brightness in August of the same year. Observations from the Hubble Space Telescope revealed that the star had ejected a gigantic cloud of hot, dense material. This then cooled down, condensed into dust, and shielded the emitted starlight. Due to the cosmic dust veil, it appeared from our terrestrial point of view as if the celestial body had dramatically lost its luminosity. Now that an explanation for the past development had finally been found, it did not take long for the star to come up with another mystery. Since 2023, Betelgeuse has been shining much brighter than usual. What happens when Betelgeuse explodes? Regardless of whether Betelgeuse will explode soon or many thousands of years from now, one thing is certain. As soon as the red supergiant transforms into a supernova, we will once again be impressively reminded of the elemental forces at work in the universe. As mentioned, Betelgeuse already shines 10,000 times brighter than the Sun, but the researchers are expecting a 16,000-fold increase in luminosity for its explosive stellar death. While some experts assume that the brightness of the star will then be comparable to that of the crescent moon at night, others believe that it will correspond to the luminosity of the full moon. In any case, the supernova would be impossible to miss from Earth. But what will the brute spectacle mean for our blue home planet? Will the Earth possibly be wiped out along with its inhabitants? Well, fortunately, it's not quite that dramatic. Basically, the concern with such constellations is that the gamma-ray explosion that will accompany the supernova will also affect the Earth. In the case of Betelgeuse, however, the experts are giving the all-clear. As the star's axis of rotation does not point in the direction of our terrestrial home, the gamma-ray burst will not be intense enough to have a negative impact on our planet. What is particularly exciting, however, is the fact that there may even be two flashes. After the explosion of the star's core, the ejected material could collide with the static shell that surrounds the red supergiant at some distance. And this subsequent collision would also manifest itself in the form of an explosion that would be visible from our blue home planet. But what will be left at the end of this thunderous spectacle? Will the former viewpoint of Betelgeuse henceforth be adorned by a yawning void? Well, most probably not. As is typical for stars of this size, this supernovae is also likely to result in the birth of a neutron star. A neutron star that is 20 times the mass of the Sun. Is Betelgeuse spinning too fast? The neutron stars in question are known above all for their unparalleled rotational speed. In 2004, researchers even tracked down a representative that rotates 716 times on its own axis within a single second. And although Betelgeuse is still a long way from being an insanely rotating stellar remnant, its rotational behavior is already puzzling astronomers. In detail, the images taken by the radio telescopes of the ALMA Observatory in Chile suggest that Betelgeuse is rotating unusually fast. In fact, the star rotates much faster than it should. With a speed of more than 5 kilometers per second, its rotational speed is about 50 times higher than would be normal for a red supergiant. As a rule, stars actually rotate more slowly the further they expand, and Betelgeuse is the only known star of its kind that is thought to rotate so quickly. But what is it all about? Well, one possible explanation is that Orion's shoulder star has literally swallowed itself up. According to this, it is conceivable that Betelgeuse has incorporated a smaller star during its rearing up. What sounds quite crazy at first is not uncommon in reality, because massive stars are known to regularly interact with their close companions. Theoretically, the stellar digestion could have transferred the angular momentum of the swallowed star to the outer shell of Betelgeuse, thus increasing its rotational speed. However, if we follow the explanations of Jingji Ma from the Max Planck Institute for Astrophysics in Garching near Munich, things could actually be quite different. After all, Betelgeuse's surface is teeming with gigantic bubbles of rising and falling plasma, so-called convection currents. And this is precisely the crux of the matter. The scientists have deduced the speed of rotation from the bipolar surface structure of the star. This is because while one half of its visible surface shows a blue shift, the other shows a red shift of several kilometers per second. However, the movement of the convection currents also cause a red and blue shift in the radio radiation. If one very large convection bubble or a group of several convection bubbles moves towards the observer and the other away from him, this can create a so-called bipolar velocity field. In this way, even a star that is not actually rotating at all can appear to be racing around its own axis at a hellish speed. However, future investigations will have to show to what extent this theory corresponds to reality. The scientists hope to be able to crack the rotation puzzle with the help of higher-resolution ALMA images. An initial series of observations has already been made, but the data is still being analyzed. And we would be delighted if you would continue your series of observations of our videos in the future. Feel free to press the like and subscribe button now and never miss another exciting video.